Thank you very much for this opportunity to speak here. I will just say a few words on the collaboration that is ongoing for a few years between the IGS Ionospheric Working Group, now IGS Ionospheric Committee, and the International Reference Ionosphere. Also, I would like to thank all the colleagues from both the groups for making it possible. So first, the most important point is that the cooperation between IGS Ionospheric Committee and IRI is concentrated on providing IRI users with reliable GNSS data that wasn't previously used in IRI, and it follows two recommendations which were given both by the IGS and IRI to include actual GNSS derived TC in IRI. So ionospheric products for IRI that we are preparing utilize assimilation environments of IRTAM and Gambit, on which I will say more in a second. And enriching IRI with GNSS TC values that we do allows for determination of different parameters of ionosphere in those environments, allowing for deeper evaluation of the state of the ionosphere that was aimed to be useful for the IRI community. Of course, Manuel said a lot about the IGS Ionospheric Committee, so I will let myself skip this one and concentrate on the other part of the cooperation. So, International Reference Ionosphere, as you can see, is an international project that is sponsored by COSPAR and URSI. For given location, time, date, you can get from IRI monthly averages of electron densities, electron temperatures, ion temperatures, and ion compositions. And what is important in what we do, you can get TC from IRI, which is derived using numerical integration of the Iono profile that is produced by IRI. But this data is not extremely reliable, so in many user cases it wasn't enough, hence the recommendations to include GNSS observations. Also, as you can see, in IRI the main data sources are the worldwide network of ionosounds, incoherent scattering radars from Gimerca, Arecibo, Wilson Hill, Malvern and St. Something, the ICS and Alouette probes, in situ instruments, several satellites and rockets, but no GNSS so far. As for the IRTAM and Gambit, the two are interconnected very strongly. Both are global assimilation models that combine IRI with actual data, mostly from those sources that I said before, including also over 17 million ionograms. Together with Gambit, we have Gambit Explorer, which is quite handy application that allows you to access data from IRTAM database to display it in different various options. Also, you can use external data as you will and produce reports from that. Also, it is very useful for visual comparisons, apart from those reports that you can generate. So here we have one simple comparison of VTEC and NMF2 parameter for the same place and time. One of the uses that Gambit developers like to point out is the generation of so-called equivalent slab thickness, which is derived from TC and NMF2. And as you can see here, it shows interesting properties, depicting more compact ionosphere around the midday, and just before the terminator, the composition of the vertical composition of ions is more pronounced, exceeding even 1,000 kilometers. So this is just one use case of the data. As for now, 2 papers were published on our cooperations. Of course, more works are being done now, and soon we can expect more papers on this topic. Here I had one technical problem because the maximum allowed weight of the presentation was 20 megabytes, so I needed to resign from the animations that I have here. But what we can see here first is the global map of TEC derived from IRI profiles, and below we can see our product, which is derived from 15 minutes product from UPC and remapped to 8 by 4 degrees resolution grid that is used in IRTAM. So what we have here actually is the derived model value of VTEC and 30-day running mean for the same date and time based on actual GNSS data, but depicting climate TEC, not observed values for this certain date, and with differences. So we have what we see here is actually more characteristic, even for different times, that IRI pronounces the northern part of ionosphere of equatorial anomaly very much, extending it far further to the west than it actually should be, as observed with GNSS. The same can be seen in quiet periods. And moving a bit back, we had a joint project called Artemis. It was between the University of Armenia-Mazur and Chinese Academies of Sciences. And one of the products that were created in the project were real-time ionospheric TEC maps using multi-GNSS approach. So this is just an example of maps that were created, but also they are now used in Gambit in IRTAM. Also, after resampling to this 8 by 4 by 15 minutes resolution that they use, and it is now available for analysis. So in this time period, of course, we see that the concentration observed in the real time is much higher than it would be predicted by the climate product that was made with 30 days running mean. For a quiet period, they are actually more similar. Also, just as for the example of anomalies in TEC image in the IRI, especially interesting thing is here that in distant times IRI has higher VTEC values at 30 degrees north than at 10 degrees north. So this is here. Also, interesting tendency that during the nights IRI gives almost zero TEC in most situations. So this is one of the reasons that we are developing both products for IRI users and that they are now quite widely used. So including real-time GNSS TEC products in IRTAM and Gambit, we extend the capabilities for analysis and generation of new products in those databases. Now both climate and real-time products show good performance and prove to be useful for the IRI community. And of course, we are still working on that, enhancing stability, reducing latency, and also we plan to move to combined products as the source of data, so especially in the real time. So thank you for your attention.